This is the third configuration challenge in the Scenario-2 labs based around setting up a medium-sized branch office network. In this, the third lab, we'll be configuring a number of VLANs using one of the network's VTP servers. Then we'll set up spanning tree in a way that switches Core-1A will act as the root bridge for all of the VLANs, with Core-1B configured as a secondary backup root bridge. And then we'll optimize spanning tree timers by using the optional spanning tree diameter keyword. Okay, before we jump into this particular lab, there is one small limitation of Cisco VIRL we need to address, and that is when extracting node configurations, it only pulls the running configuration, and as VTP config for clients and servers are not stored in the running configuration, but the VLAN.dat file, these configurations are lost when logging out of VIRL. So for the purposes of this lab, we first need to recreate the VTP setup that we had applied in an earlier scenario 2.1 before we proceed with this particular lab's configuration goals. So I'm going to quickly jump in to the core switches and the user access switches and apply that VTP configuration real quickly. Sorry, up, Conf-T, and I'm simply going to just copy and paste the configuration needed for the switches. Enable, level up, configure terminal, just paste that in. And then we'll jump into the 4 user access switches. And finally, the last of the switches that need VTP configuring. User access 2A is going to level up, configure terminal, and we'll paste the VTP config. And conversely, upon completing this lab, we'll want to change all of the switches' VTP configuration using VTP transparent mode, which will in turn add VLAN configuration to the running configuration. Moving back to the tasks associated with this particular lab, we will first want to confirm the VTP is operating as expected by checking the VTP status of some of the switches. So we want to confirm the core switch A is running as a VTP server. VTP status, sorry. It's running version 2, there's the domain, and there's its operating mode. Likewise, we can jump onto one of the user access switches, run the same command, and here we can confirm it too is running the same version that we configured earlier with the correct VTP domain name, and that this switch is in fact operating as a client. Now we know that VTP is working, we can now jump back into core switch 1A, which is a VTP server, and we'll apply the necessary VLAN configuration, and then VTP will address the propagation of those VLANs to all of the other switches throughout the topology. I'm simply going to take a snippet of configuration I put together earlier and just paste it in, as all we're doing is configuring some layer 2 VLANs. Next, we should verify that the new VLANs have in fact been propagated across the network via VTP by logging onto the other switches and issuing the show VLAN or show VLAN brief commands. So we'll start with a core switch. Show VLAN brief. And here you can see the new VLANs, VLAN 10, 20, 30, 100, 101, 200, 201 are all active. Likewise, if I jump back onto one of the user access switches and issue the command show VLAN brief, you'll see that the VLANs have been learned by VTP. Now that the VLANs have been configured and propagated throughout topology, we'll log back into the core switches and configure spanning tree. So, as mentioned earlier, we want core switch 1A to act as the primary route bridge for all the VLANs throughout the network. And we're going to optimize the spanning tree timers by using the diameter keyword to limit the size of the spanning tree network to 3 bridges. Route primary, and we'll set the diameter to 3. Next, we'll jump onto Core-1B. Level up. First, we'll check that the VLANs have been propagated. And there they all are. And we're going to set Core-1B as the secondary route bridge. This means that if Core-1A was to ever fail, we know that Core-1B would take on the role as the route bridge for all the VLANs. Configure terminal, spanning tree, VLAN 1, 10, 20, 30, 100, 101, 200, and 201 route secondary, and set the diameter to 3. Now that we've configured the network's spanning tree topology, we should quickly verify its functioning as designed. So we'll jump back onto core switch 1A and verify that it is in fact the route bridge for all of the VLANs in the topology. We'll simply issue the command show spanning tree. Here you'll see for VLAN 1, this bridge is route, 10, route, 20, route, 30, route, and so on. And this concludes the goals for this particular lab. However, before we log off, there is one last admin task we need to address, which is to change the VTP mode on all the switches to ensure that the new VLANs that we've configured will be saved to the running configuration for use in future labs. So VTP mode transparent. So configure level up. Configure terminal. VTP mode transparent. Exit. And then let's verify that new VLANs now exist within the running configuration. by looking at the running config. If we scroll through, we should see entries for the layer 2 VLANs, and there they are.